Good morning, good afternoon, or good evening, depending upon where you live around the world. Here's a little look at an idea I've had when I was drawing up some of the details of the dome, and I thought, when is information too much to deal with? And it's when you start going down the rabbit hole of the angles that make up a dome. And you look at this drawing here, which is really a truncated section of one quadrant of the dome, and you start to realize just how many angles there are in a dome. This is just the surface angles. If we hide this, we've got the internal angles of the planes upon which the struts may need to be or information around the struts when they're drawn that you may need. And then we can add the angle of the two surfaces. Why is that important? Well, it may not be for most of the instances of or the situations that you'll need, but when you've got a situation where you need to create a angle on a strut, you'll need these sorts of angles, because a strut angle on one side won't be the same angle on the other. So you can't just set your bench saw up or router table if you've got a tilting router and do it the same on both sides, as we can see here. Information overload, I think, might be the situation that I'm considering, but this all came about because I was quite puzzled by the inability of myself to create my hubs. And in this regard, I'll just delete some of this out so it's less confusing, maybe. But I've gone back to the circular hubs. I was actually trying to do the angled hubs themselves so that the struts don't need to have an angle cut on the ends. The angled hubs mean that all the struts would have a square cut. But I kept on running into the same problem, that the points upon which the surfaces of the hub, they wouldn't intersect each other. And it kind of makes sense when you think about it, hence why I got the angles in that other drawing, is that all the struts meet at the center point, the geometric center point of the intersection. All's fine there. But dependent upon the angle of the strut relative to the, this is where it gets complicated, if I run a line through the hub to the geometric center of the dome, then these hubs, the struts on the hubs, will create a different angle and therefore a different measurement where they touch another solid surface. Like you can see here, it's only 2 or 3 millimeters here, but as you swing around you can see, well, it's a lot more than 2 or 3 millimeters. Why is that important? Well, if you're stretching a vinyl or a plastic surface over this, or a tarpaulin type structure or material, you'd really like to have no projections through that would create a wear potential. More importantly for me, I can get round that to a certain degree, is the aesthetics. Don't you want it where all the surfaces meet perfectly? Because it kind of like would say, got that right, I got the drawing and the details right. But I don't think there is such an animal where, not using struts like this, where you can get all the surfaces aligning. Because you'd have to go back to the drawing I just showed you, where each side of the strut would mean that I'd had to bevel this at a different angle to this side to make it all match up. the drawings that I've used in the past show you the metal hubs that everything appears to align. And this is the sort of photo I've been referring to. It looks like the struts line up, but when we take a closer look, we can see here how they've done a nice finish to the edges and they've put a small radius on it. Well, that surface there actually hangs down below the metal hub, but this one sits up slightly, and we are only talking about a few millimeters. And sometimes in our effort to create in our mind an understanding of what we see, we can actually trick ourselves. It may well be that the examples that we see via a photo are showing a reality, but a perception of it is something other than what is achievable, and we try to achieve the impossible. So this hub is the hub in this section in here, and because there are different angles on each strut, it would of course mean that the length of the angled cut would be different, and therefore no metal hub could be created where they all come flush at the top and the bottom. So you're going to have an inbuilt fudge factor in the creation of your hub, or the placement of the struts relative to the hub. It would otherwise you'd have to have your surfaces angled, and the looks of that would be, I think, quite unpleasing. Again, a photo that I've drawn in from my collection shows a similar situation where this obviously hangs down, this strut here obviously hangs down below the metal, and this one sits up from the metal. This one's slightly down, there's a bit more down, this one's just right on it. This one I would suggest hangs down because they've taken the radius off of it a little bit by the looks of it. But when you look at these in the overall picture or a photograph, you will see in your mind a perfect join where everything lines up. Now it may want to be more flush along the surface because of that reasoning I was giving about when you put your cladding material on, and any discrepancies that are going to be created can be made here on the bottom. But is that aesthetically pleasing? And that's the question that you're going to have to resolve before you start building, because the placement of the fixings are going to be critical in your working drawings and your technical drawings. So that now when we've got this sort of photo, we can zoom in and assume the surfaces all match up beautifully with the surfaces of the hub, and they probably do, but do they do so on the bottom? And that's where, if we try to obtain the theoretically flush surfaces here, we may be chasing you'd be chasing a shadow. When you make the circular hub versus this hub, you swap one problem for another. You eradicate the need to have angled cuts on your timbers, your struts, but you have to build in those compromises in the steel, or accept that they're not going to be flush. Also, the height that you'd have to lift up or lower down each strut becomes a question of the inaccuracies that you're going to have to accept And this is all just basing it on conjecture at the moment because I haven't built one. And these people may have worked it all out and think what I'm talking about is a lot of twaddle. But because of my building background, one of the things that just as an aside, you're trying to do a handrail around a corner, and the compound angles don't really work the way you think. So the joiners that have learnt how to do that, I take my hat off to them. It's a bit of a geometry and trickery that is quite interesting. And I've done them in the past, and they've been a bit tricky for this builder, and that's why specialists have their skills that are specific to them. Ditto here. Whoever drew this have engineering knowledge that I don't have, or drawing skills that I don't have currently. But also it may be that I'm working on a theoretical idea of the ideal situation which doesn't actually exist. Am I correct? I really don't know. So this is why right back at the beginning of the series I said this will be a journey, and I'm contemplating whether to delete some of the videos, or well, I probably will, in the series. They just don't get loaded so that you can see, because a lot of it is just my going down a rabbit hole or blind alleys. But you're going to have to do that yourself eventually if you're going to understand the structure upon which we're trying to or we're trying to build. So this lovely drawing makes you think that everything's flush top and bottom. I don't believe they can be. If you tried to do that, you'd actually have to have each face distorted to try and join them together as each plate on each strut mates up. And I'd like to see one of these in the flesh, a good quality one of these in the flesh. Then you could see the acceptance or not of the points I've been making where they don't all line, everything doesn't all line up. Okay, that was a wee bit of a confusing or confounding issue that I'm trying to resolve, but coming to perhaps a realization that those that have actually created these structures have already accepted that there are limitations, and we also have to come to that realization. I prefer to think everything could work out perfectly, but I've got a feeling that we will come to that conclusion where there is a fudge factor in the actual design right at the get-go. Unsatisfactory, but it may be reality. Okie dokie, that's it. I'll tootle off. It's warm outside, and I'm going to head out and do some work. Alright, see you later. Bye.